Okay, chain rule day 2, ladies and gentlemen, is going to be a little more complicated than yesterday. However, we still will probably be using the chain rule. Some of these more complicated functions. Again, the farther we go, the more complicated some of these functions get, the more rules we know. And again, you have to do your homework. Make sure your bookwork is being done. Do not halfway do your homework. You're not going to do well on the quizzes or test. I guarantee you, it'll separate the people who practice versus those who don't. Guaranteed. Every year it does. Are we ready?
Yes.
Are you sure?
Absolutely.
He wasn't ready. Alright, f of x equals x squared square root 1 minus x squared. Okay, just like yesterday, there's some things we've got to figure out. Inspect the function and see what's going on. What is the overall operation that happens here that will drive our rules or theorems or whatever that we're going to use to find the derivative? Okay, what's happening here, guys? Multiplication. So what rule are we going to use? Product rule. Okay, so we'll have to start with that. Any rewriting we want to do first? Yeah, get rid of this radical. We'll get to a point where we really don't need to do that. However, I highly recommend you do. Some of us, we can visualize things in our mind better than others. Some of us others would need to write it down. I like if we write it down. It takes less time a lot of times, actually. And you just do instead of think about it. Don't think, just do. And we better write f prime, right? F prime x equals first x squared times derivative of second. Ooh, the second factor is a composite function. This is where we will definitely need the chain rule, right? Okay, let's find the derivative of this composite function. So it'll be derivative of the outside function, 1/2 of the stuff of the inner function. So it'll be what, negative 1/2? Times the derivative of the inner function. The derivative of the inner function looks to be negative 2x because the derivative of 1 is still 0. Are we done? No, that's just the first part of the product rule plus the second times the derivative of the first 2x. Are we good so far? Alright, that is a derivative, but let's simplify this a little bit, reorganize some things. Okay, x squared is upstairs, 2 is downstairs, this stuff goes downstairs, this is upstairs, so it'll be, oh, 2's will cancel, won't they? Okay, it looks to be negative x cubed on top. Is that right? All over. That'd be 1 minus x squared to the 1/2 plus, let's see here, well, I usually just put the 2x in front. 1 minus x squared to the 1/2 power. And that'd be alright, except for in the future I know we need to find out when the derivative equals 0 or when the derivative is undefined, right? When you have one fraction, we better, one term that has a fraction in it, we better make this one fraction by combining these two terms with a common denominator. Okay, and the answers in the back of your book, I think they're all one term, right? One fraction. They don't have a couple terms listed out. So we got to get good at this to be able to check our answers. And in a multiple choice test, the answer might not be this. They might have added the two terms together. You got to be able to do it. So common denominator would be this denominator. So we need to multiply this term by 1 minus x squared to the 1/2 power, top and bottom, so we can add. Okay, so looks like the denominator would be 1 minus x squared to the 1/2 power. And sometimes it will be written as a radical. I'm okay with rational exponents. I've told you that already. Okay, so we have negative x cubed plus 2x times whatever the product of 1 minus x squared to the 1/2 times 1 minus x squared to the 1/2 power is. There are two ways to think about this. Number one, they're like bases, right? 1 minus x squared is the base. What do you do with like bases when you're multiplying? You add the powers. So what's 1/2 plus 1/2? That'd be 1, right? Okay, so that'd be 1 minus x squared. The other way to think about this is a square root times a square root. What happens? You multiply the two square roots together, cancel with the like radicands. Okay. I know I light you guys up about distributing. However, these are terms now. We should probably distribute this in combined like terms. If this was all products in the numerator, I would say leave it alone, right? But since we have terms, I definitely think we should distribute right here and then combine like terms. Let's do that. 2x minus 2x cubed all over 1 minus x squared to the 1/2 power. Alright, let's see here. That'd be what, negative 3x cubed plus 2x all over 1 minus x squared to the 1/2 power. Alright, you might be asking, well, Mr. Bonnie, would you maybe factor out an x? You could. I would leave like this right now, though. Okay? We can't cancel the factor x down here anyway, so I'm okay with this. This is definitely a good answer. I could definitely take that numerator, set it equal to 0, and find out when the derivative equals 0. I could definitely take the denominator, set it equal to 0, and find out when the derivative does not exist. Okay? And actually, you should be able to figure that out just by looking at it, but yeah. Oh, good call. Cube, cube, cube. Anything else? We good? All the rest of my math is good? Alright. Not too bad, I think. Again, you know, this is the calculus. This is algebra. Alright, what do we think on this one? Quotient? Quotient? Think we should use a quotient rule? Any other way to write this at all? Okay, you can do that. So x over x squared plus 4 to the 1/3 power. All right. You guys want to use the quotient rule? All right, see what you can get. If you think there's another way to do this problem, go ahead and try that way. Help me out. We'll use the quotient rule for this one. If some of you guys use the quotient rule. Okay, this would be what, f prime of x equals low d high minus high d low. Okay, the low part, that is a composition, right? So we have to use chain rule for the derivative of this part. So the derivative of this would be 1/3 of the stuff. What would that be? Negative 2/3 times the derivative of the stuff would be 2x. Correct me if I'm wrong, if I see a mistake. Over low squared. We okay if I just do x squared plus 4 to 2/3? We okay with that? Good so far? Yes or no or what? Okay, low, d high minus high, d low, 1/3. Yeah, looks good to me. Now this is kind of a mess a little bit. Okay, let's see here. Ooh, looks like we're gonna have a complex fraction, kids. So that's gonna be x squared plus 4 to the 1/3 power. minus, okay, x is on top, 3 is on bottom, 2x is on top, this stuff goes on bottom. Looks like 2x squared on top. And then we have 3 times x squared plus 4 to the 2/3 power now. All over x squared plus 4 to the 2/3. Okay, great. Well, we better combine these two fractions. So I need 3 times this stuff, top and bottom. 3 times x squared plus 4 to the, was that 2/3 power? I keep writing a 2 today. I don't know what's going on. All right, 3 times this times this. Like bases, add the powers. 1/3 plus 2/3 is 3/3. So it's just going to be 3 times x squared plus 4. Minus 2x squared. All over. Ooh, I don't want to do all over again. Let's multiply by the reciprocal. How are we doing right here so far? Okay, that's going to be 3x squared plus 12 minus 2x squared all over 3 times, okay, like bases, multiplying, add the powers, looks like 4/3. That's a 4/3. And then I'm going to put an equal sign this way. That's just x squared plus 12, isn't it? All over 3 times x squared plus 4 to the 4/3 power. All right, I'm going to change colors. And we'll do the same problem, but let's use a product rule. Because you guys said f of x, we could change this to a product. X times x squared plus 4 to the negative 1/3 power, right? And that's the way you did it. Okay, let's see what happens. Okay, product rule. First, oh, I better write f prime though. First times derivative of second. Negative 1/3 x squared plus 4. Subtract 1, there's minus 4/3. 4/3 times 2x plus the second. I'm gonna run out of room, aren't I? I'll just put it down here. X squared plus 4 to the negative 1/3 times the derivative of first 1. Okay, equals. All right, let's figure out some stuff here. That's a negative exponent. It's going downstairs. We have negative 1 on top. We have x. We have 2x. So it'll be negative 2x squared on top. We got 3 times x squared plus 4 to the 4/3 on bottom. And then over here, looks like we're going to have 1. Oh, not equals. That should be a plus, right? Plus 1 over x squared plus 4 to the 1/3 power. Okay. All right. Let's see here. Let's combine these two fractions. Common denominator. However, how many times have you guys ever done this in your life? Common denominator with these rational exponents. Okay. Well, I know we need a 3, right? We need a 3. And the common denominator, well, these are like bases, so you just take the higher power, 4/3. Now, what do you have to multiply this base by, this denominator by, to get 3 times x squared plus 4 to the 4/3 power? Well, obviously, you're going to multiply by 3. And then you're going to multiply by x squared plus 4 to the 3/3 power. Okay, which would just be x squared plus 4. All right, so you're multiplying by 3 x squared plus 4 top and bottom. Because x squared plus 4 to the 1 power is 3/3. 3/3 plus 1/3 is your 4/3 power that we need. Alright, negative 2x squared plus, looks like 3x squared plus 12. And then it looks like we're back at x squared plus 12 all over 3 times x squared plus 4 to the 4/3 power. I think in this case, making this a product benefited us a little bit. Okay, we didn't have that complex fraction to deal with that a lot of us are scared of. But, I mean, how much different is this than this? It's not much different, okay? So we should be able to take care of this and just ignore this for a second, put it as multiplying by the reciprocal, leave it out here, and then just multiply in the end, okay? Anybody make mistakes on this we want to talk about? Where will the mistakes happen? Probably combining like terms, right? Common denominator. It's usually where the mistakes are made. What about this one? These are definitely big kid problems today. Resiliency is definitely needed. How do you guys want to attack this one? What do you think is going to be the best way to start this one? Because we've never done a problem like this before. Should we derive it the way it's written? Because this is a composite function where the inner function is a quotient, which means we're finding the derivative of a quotient sometime. Or do you guys want to take that power, use your power rules, and make it 3x minus 1 to the second power all over x squared plus 3 to the second power? Use a quotient rule? Or do you guys want to turn it into a product? What do you think? What are you going to do? Leave it how it is? Or change it?
Let's change it.
Change it? You think so?
I just leave that.
Leave it? You think so?
Let's change that.
You guys are really good at reading teachers' reactions, so when I say you think so, you're always like, you're doubting yourself right away, aren't you? Alright, I would leave this one the way it's written right now. Let's see what happens. Let's see what happens, okay? So, y prime then would be, okay, this is a composite function, derivative of the outside, 2 times the stuff, to the first power times the derivative of the stuff. Well, the inner function is a quotient. Let's find the derivative of a quotient. Low d high, derivative of the upper function is 3, minus high d low, 2x, all over low squared. No, honestly, that's not too bad. Look at the bases on the denominator. That's going to be x squared plus 3 quantity cubed. That's not bad. We have 2 times 3x minus 1. I am not distributing here. I am going to distribute and combine like terms here, though. Okay? Let's do that. So in the numerator, we're going to have 2 times 3x minus 1 times, what's that, 3x squared plus 9 minus, okay, 2x times 3x times negative 1, that would be negative 6x squared. 2x times negative 1 times negative 1 plus 2x all over x squared plus 3 cubed. All right, I just think we just combine like terms here. Maybe we could factor and cancel one of these x squared plus 3's. I don't think it's going to happen though. Okay, that'd be what? Negative 3x squared plus 2x plus 9. All over x squared plus 3 cubed. We easily could set the numerator equal to 0, could set the denominator equal to 0, and do other things with this derivative if need be. Questions? Mr. Molly, how am I going to know what to do? Well, just pick a way and do it. If it feels like you're taking too long to find the derivative, cut your losses, go back and find it the other way. Okay? Again, just so you guys can visually see this, remember we could rewrite this function as 3x minus 1 squared over x squared plus 3 squared. And you can just use a quotient rule to start. You'd have low and then d high. Well, when you find the derivative of this upper function, you're going to have to use a chain rule. Minus high, d low, the derivative of lower function is chain rule, all over low squared. And that means you're going to have x squared plus 3 to the 4th power, and then eventually you're going to have to cancel one of those factors. Okay, so that's going to be a little bit more work, I think, than this way. Well, Mr. Molly, what if I did 3x minus 1 squared times x squared plus 3 to the negative 2 power turned into a product? Because every quotient you can turn into a product. I want to use the product rule. Well, each derivative of the first or second is going to require the chain rule anyways. And then you got negative exponents. Subtract 1 from the negative exponent means you're going to have more fractions later on to add and subtract. Okay? So it all comes with practice, and that's why we're going to do our homework and get good at this stuff. Well, let's talk about some trig functions. All right, before we've just found the derivative of sine, but now we have sine of 2x. While the inner function, the argument of sine, is a function itself, it's more than just x. Okay, so with sine of 2x, we definitely need a chain rule for this one. That means that y prime equals the derivative of the outer function, which would be the derivative of sine, which is cosine, right? Of the inner function, which is 2x, times the derivative of the inner function. The derivative of the inner function would be what, 2? And we don't leave our trig functions written like this. We put that 2 in front. And you can leave it like that, or you can put parentheses around the 2x. Doesn't really matter. Okay, not too bad. Letter B, cosine of some stuff. Definitely looks like inner function x minus 1, outer function cosine. So y prime then is derivative of the outer function. What's the derivative of cosine? Of the inner function times the derivative of the inner function. 1. I really like that type of inner function. Look at that. X minus 1. What's the derivative of this all the time? What if it's x plus 5? What if it's x minus 7? What's the derivative? So it's a linear function, lead coefficient 1. That derivative is always 1. So it makes the chain rule nice and easy. Okay? But we got tangent down here, tangent of 3x. That's definitely a composite function. Chain rule needed. Y prime equals, oh man, derivative tangent, secant squared of times, okay, we're putting that 3 in the front again, 3 secant squared 3x. Fun fact, fun question, what's another way to write secant squared? So secant 3x square like that,
Yeah, times 3.
then times 3. Okay, that could happen. Typically, we're gonna write it like this. But why do you think I'm asking you guys about this?
And take the second derivative. It's
That's a composite function again, right? Yeah, you're definitely need the chain rule twice on this one actually, because that's an outer function, inner function, inner function. It's 3x. Crazy. All right. How about some more? Letter A. Okay, cosine 3x squared. You just got to assume that 3x squared is the argument of cosine. Sometimes we'll put parentheses around it. Okay. What's the outer function? Well, definitely cosine. What's the inner function? 3x squared. Okay, so we have to find y prime or dy dx. Derivative of the outer function would be sine. What is that?
Isn't it negative?
Oh, it's negative. Derivative of cosine is negative sine of what? Say again? Oh, we don't take the derivative yet. Yeah. So the derivative of the outer at the inner times the derivative of the inner, which would be what, 6x? And I would definitely rewrite this as negative 6x sine 3x squared. Don't really think there's parentheses really needed right there, but I wrote them anyways. You could put parentheses around the 3x squared if you wanted to. It's up to you. Letter B. What is going on there? What's significant of cosine of 3? What is it, Edlin?
Negative 0.9899.
So what is it then?
0.99.
What is it?
Or negative 1.
Why would we treat this problem different than letter A?
Because it's just like use the product rule.
You guys want to use the product rule? I wouldn't. Why not? What is this? Looking for a very specific word. It's a what?
It's a number.
It's a number. Huh?
So it'd just be 0.
What do you mean? Isn't that just like putting a 2 in front of the x squared? It'd be like 2x squared. How would you find that derivative? This is just a number times x squared. So cosine of 3, that's just a constant. That's just a number. That's just a scalar multiplier, right? That is a number. Okay? So we don't need a product rule. That's a scalar times x squared. So what's y prime then? Well, cosine 3 times 2x, which we'd normally rewrite as 2 cosine 3 times x. Because cosine 3 is a number. Now if there was an x inside this, what's it, cosine 3x, completely different problem. It would definitely be a product rule problem. Okay? Alright, letter C. Okay, cosine 3x squared. Well, using your power rules, you can make that 9x squared. Okay? Y prime then would be derivative of cosine is the negative sign. I'm not going to try and pull a fast one on you guys yet. You think. Negative sine of the stuff, 9x squared, times the derivative of the inner function, 18x. And what would that be? Negative 18x sine of 9x squared. We'll put parentheses around that for fun. Okay, letter D highlights what we just talked about in the last slide, cosine squared x. That's just a better way of writing cosine x quantity squared. Okay, so this would definitely be a composite function. Definite chain rule needed. Okay, y prime. Derivative of the outer function would be 2 cosine x to the first power times the derivative of the inner function, negative sine x. And so we could rewrite that as negative 2 cosine x sine x. Sometimes people put sine before cosine. Doesn't really matter, I don't think. Okay. Looking at letter E, they already did the rewrite for us, so that's kind of nice. Definite composite function set up again, though. There's definitely an outer function, the 1/2 power, inner function cosine x. Therefore, y prime is derivative of outer function at the inner function. It will be what, negative 1/2 power times the derivative of the inner function, negative sine x. Okay, rewriting. Looks like negative sine x stays on top. 2's already in the bottom. Cosine x to the 1/2 power downstairs. Can we make this into tangent? Because tangent sine over cosine? No. Powers are different, so we can't combine these at all. Okay? If this was sine to the 1/2 power, well, maybe we can make a tangent to the 1/2 power then, but not the way it's written here. Okay? So there's many different ways for us to write these arguments and these functions and add a whole bunch of complexity to these issues. These functions, you have to sort your way through them, inspect, look at what's going on, and choose your weapon accordingly. Are you using chain rule? Are you just going to find the derivative using the power rule? Okay. Last one. See what you can do. Okay, are we rewriting this one before we find the derivative? Yeah, what would that be then? You mean quantity cubed, right? Yep, I gotcha. Ooh, what in the world? So we have an outer function cube, inner function sine, inner function 4t. What? What happens with this? Okay, f prime of t then. I know some of us wrote down x. That happens. Okay, let's find the derivative. Outer function, that'd be what? 3 at the inner function, sine of 4t squared, okay, times the derivative of the inner function. Now guys, if we found the derivative of sine of 4t, we'd have to use a chain rule on that. If we just found the derivative of sine of 4t, well, that's exactly what you're doing right now, is finding the sine of 4t. That is a composite function itself. Outer function sine, inner function 4t. Got to use a chain rule on this one, okay? So derivative of sine of 4t, derivative of sine is cosine at the inner function times the derivative of that function now, times 4. Okay, simplifying, it looks like we're going to have 12. I'm putting cosine 4t first. And then I'm putting sine squared 4t second. And boom, we are done. Questions on this? We know how to handle a situation like this now. Just keep taking the derivative. Keep taking the derivative of the inner function. Cool? Pretty heavy stuff today? That's all right. It's just algebra.